10th CBSE Mathematics, Chapter Coordinate Geometry. After watching this video, you will be able to find the distance between two points whose coordinates are given. Let us use distance formula to find the distance between two points. Let us take the point A -2, 1 and B 2, 4. Let us plot these points on the coordinate plane and find the distance between A and B. The point A is here and the point B is here. Let us join AB. Let us now draw lines and form a right-angled triangle using these 2 points. We see that these 2 lines meet at the point C, and ACB is a right-angled triangle. Now let us find the length of the horizontal side of the right-angled triangle, which is AC. To find the length of the side AC, we subtract the x values. The x values here are 2 and -2. So AC equal to 2 minus of -2. Let us also find the length of the vertical side of the right angle triangle, which is BC. For this we subtract the y values. The y values here are 4 and 1. So BC equal to 4 minus 1. We can see that ACB is a right angle triangle and AB is the hypotenuse. So we can use Pythagoras theorem and find AB. So AB square equal to AC square plus BC square. AB equal to square root of AC square plus BC square. AB equal to square root of AC we have already found out as 2 minus of -2 the whole square, plus BC we already know as 4 minus 1. So we write 4 minus 1 the whole square. Solving this, we get AB equal to square root of 4 square plus 3 square, which is equal to square root of 16 plus 9, which is equal to square root of 25, which is 5 units. Hence we have found AB as 5 units. Now if we have to find the distance between 2 points x1, y1 and x2, y2, we can find the distance between these 2 points by drawing a right angle triangle like we drew before. We can also find the length of the hypotenuse using the Pythagoras theorem. The length of the hypotenuse is the distance between the 2 points, and this is the distance formula. The distance formula is given by d equal to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. We can take any one of the 2 points as x1, y1. The other point will be x2, y2. The distance will be the same as we are squaring the x and the y coordinates. Let us recall some of the properties of quadrilaterals, as we will use these properties to solve examples on finding the distance between 2 points. Let us take a rectangle. In a rectangle, the opposite sides are equal and the diagonals are equal. In a square, all the sides are equal and the diagonals are equal. In case of a parallelogram, the opposite sides are equal and the diagonals are not equal. In case of rhombus, all the sides are equal and the diagonals are not equal. Let us solve some examples on distance formula and also use the properties of these quadrilaterals. Let us solve this example where the points A 2, -1, B 3, 4, C -2, 3, D -3, -2 are the vertices of the quadrilateral. We have to identify the quadrilateral. Since we have to identify the quadrilateral, let us use distance formula and find the distances AB, BC, CD and DA. The distance formula between the points A, x1, y1 and B, x2, y2 is given by AB equal to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Let us first find the distance AB. For this we write the coordinates of A as 2, minus 1 and B as 3, 4. Let us mark this as x1, y1 and x2, y2. Let us find the distance AB as equal to square root of x2 minus x1. So 3 minus 2 the whole square plus y2 minus y1. So 4 minus of minus 1 the whole square. Solving this we get AB as equal to square root of 1 square plus 5 square, which is equal to root of 26. Let us find the distance BC. For this we write the coordinates of B as 3, 4 and C as minus 2, 3. Let us mark x1, y1, x2, y2. Let us find BC as equal to square root of x2 minus x1, so minus 2 minus 3 the whole square plus y2 minus y1, so 3 minus 4 the whole square. BC equal to square root of minus 5 the whole square plus minus 1 the whole square, which is equal to root of 26. Let us now find the distance CD. The coordinates of C are minus 2, 3 and D is minus 3, minus 2. Again we use the distance formula. So CD equal to square root of minus 3 minus of minus 2 the whole square plus minus 2 minus 3 the whole square. So CD equal to square root of minus 1 the whole square plus minus 5 the whole square, which is equal to root of 26. Let us find the distance DA. The coordinates of D are minus 3, minus 2 and A is 2, minus 1. Let us mark x1, y1, x2, y2. So we have DA as equal to square root of, again using the same formula, distance formula. So we have 2 minus of minus 3 the whole square plus minus 1 minus of minus 2 the whole square. So we have DA as equal to square root of 5 square plus 1 square, which is equal to root of 26. Now we have found AB as root 26, BC as root 26, CD as root 26 and DA as root 26. Since all the lengths are equal, the quadrilateral is a square or a rhombus. Now we have to find out if the quadrilateral is a square or the rhombus. For this we find the distance of the diagonals. Let us find the distance of the diagonal AC. Let us mark this as x1, y1, x2, y2. AC equal to square root of, again use the distance formula. So minus 2 the whole square plus 3 minus of minus 1 the whole square. So we get AC as equal to square root of minus 4 square plus 4 square, which is equal to root of 32. Now square root of 32 can be written as root of 16 into 2. So we can write this as 4 root 2. We have found the length of the diagonal AC as 4 root 2. Let us find the length of the diagonal BD. Let us write the coordinates of B as 3, 4 and D as minus 3, minus 2. Now let us mark x1, y1, x2, y2. So BD equal to square root of minus 3 the whole square plus minus 2 minus 4 the whole square, which is equal to square root of minus 6 the whole square plus minus 6 the whole square, which is equal to root 72. Root 72 can be written as square root of 36 into 2, which is equal to 6 root 2. Hence we have found the length of the diagonal BD as 6 root 2. Since the diagonals are not equal but all the sides are equal, this quadrilateral is a rhombus. Let us take a real life example where there is a cornfield and it is fenced around the 4 poles A, B, C, D. that are on the edges of the field. The 4 poles are at A -1, -1, B 3, -1, C 3, -4, and D -1, -4. The farmer starts at the pole A and walks the entire border of the field. We have to find how many kilometers he walked. Since we have to find the number of kilometers he walked, we have to find the perimeter of the field. For this, we have to find the distances AB, BC, CD and DA. We can find these distances using distance formula. The distance formula between points A, x1, y1 and B, x2, y2 is given by AB equal to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Let us first find the distance AB. Let us first write the coordinates of A as -1, -1 and B as 3, -1. Let us mark this as x1, y1, x2, y2. So we have AB equal to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So AB equal to square root of 4 square plus 0, which is equal to 4 kilometers. Let us now find the distance BC. Let us write the coordinates of B as 3, -1 and C as 3, -4. Let us mark this as x1, y1, x2, y2. So BC equal to square root of 3 minus 3 the whole square plus -4 minus of -1 the whole square, which is, so BC equal to square root of 0 plus -3 the whole square, which is equal to 3 kilometers. Let us now find the distance CD. Let us write the coordinates of C as 3, -4 and D as -1, -4. Let us mark x1, y1, x2, y2. So CD equal to square root of -1 minus 3 the whole square plus -4 minus of -4 the whole square. CD equal to square root of -4 the whole square plus 0, which is equal to 4 kilometers. Let us now find the distance DA. Now the coordinates of D are -1, -4 and A is -1, -1. Let us mark x1, y1, x2, y2. DA equal to square root of x2 minus x1, so -1 minus of -1 the whole square plus -1 minus of -4 the whole square. Solving this, we get 0 plus 3 square, which is equal to 3 kilometers. Hence we have found the distance AB as 4 kilometers, BC is 3 kilometers, CD as 4 kilometers and DA as 3 kilometers. Since the farmer walked the entire border of the field, we have to calculate the perimeter. So perimeter equal to perimeter of the field is equal to AB plus BC plus CD plus DA, which is equal to 4 plus 3 plus 4 plus 3, which is equal to 14 kilometers. Hence we have found that the farmer walked 14 kilometers around the field. In this video, we have learned to find the distance between 2 points using distance formula, solved examples on finding the distance between 2 points.